In this video, we will talk about calculating a slope, the interpretation of a slope, but we won't get to the significance testing of slope. We need to do that in another video, mainly because we need the intercept first. So here are two equations. There's multiple different equations for a slope formula. I'm going to show you these two. I'm going to choose to teach you this one though, because it's pretty quick and it's similar to the correlation one that we learned before. But this bottom one you could also use. So you could use either one and you'll get the same answer. And so this top one is generally quicker to use, and that's why I want to use it. And it is in the total squared variability. So it's a total square variability, either in the relationship or just in the x. And then this other formula here is kind of in the average squared variability. Not exactly, because of degrees of freedom, but it takes in account sample size. So it takes into account the ends. But what happens is the n and the top and the bottom cancel out, and then you end up with just this formula here. So this formula on top is a little bit quicker than the bottom one. So that's why I'm going to choose to teach you the top one. And basically, we're going to take the sum of the products. So you should remember these terms a little bit from the correlation section, or the correlation phase. And then we're going to divide by the sum of the squares for x. Okay? The sum of the products divided by the sum of squares for x. And kind of in a general form, to kind of understand what this formula is doing, is we're taking the variability accounted for by the relationship. That's the top part, the sum of the products, is the variability due to the relationship, and divided by the total variability in x. And so basically we're taking out the variability in x by dividing by it so we can get the slope. So we can predict for each additional unit in x added, we know what y is. And so that's just basically what we're doing by dividing by the variability in x. And so we can say for each one increased unit in x, y increases this amount. Okay, that's the basic formula for a slope. So I'm going to use this data for an example, and it's a very small data set just because we're doing it by hand. We have 5 students here, and they took a midterm and a final, and here are their scores. So for example, this is student 1. They got an 84 on their midterm and a 72 on test 2. And another example would be student 4 got a 77 on test 1 and a 91 on test 2. This is just the data we're going to work with. Remember, each student gives 2 observations. So the data is kind of paired. And both variables are scale. So the points on test 1 is a scale variable, and the points on test 2 is also a scale variable. So here's a scatter plot of the data. It has each of the 5 students. You can see there's 5 points, so there's a point for each student. For example, student 2 is this point. And they had a 50 on the first test and an 84 on the second test. So their point goes here. Okay? Then there's the other 4 students over here. And then I had my computer make this line of best fit here. And you can see that's almost 0, but a little bit positive. You can see it's kind of going up a little bit. And you'll see that in the slope. It's positive, but it's not very big. I'm going to show you how to calculate the slope kind of by hand, but with Excel. And I'm just going to use Excel as kind of a fancy calculator, so you don't have to do everything by hand and type it in. It takes a little longer. But I'm not going to use the data analysis toolpack yet to just let Excel do all the work for me. I'm going to kind of do it by hand to see what Excel is doing behind the scenes. So don't think you have to do this every time when using Excel to get the slope, but this is just kind of the long way so you know how Excel is doing it. Okay? So here is our equation for slope, right? Remember, it's the sum of the products divided by the sum of squares for x. And first we need to determine which is our x variable. So here is our data. We have 5 students, and they took a test 1 and a test 2. And it's just for some classes made up data. And so say student 1 made an 84 on test 1, maybe it's their midterm, and for their final they made a 78. And another example is student 4 made a 77 for test 1 and a 91 for test 2. Okay? So the first step is to get the sum of the products, and if you remember the first step for doing that, if you remember from the correlation phase, the bivariate phase is to get the mean of both x and y. But again, we need to figure out what x and y are, which one is which. So we say that x predicts y. So x is the predictor variable and y is our outcome variable. So if test 1 is our midterm and test 2 is our final, we want to predict forward, not backward. So we're going to say test 1 predicts test 2. So we're going to say test 1 is our predictor variable and test 2 is our outcome variable. So test 1 is going to be our x variable and test 2 is our y variable. In this case, it wouldn't make sense to reverse this. It wouldn't make sense to say this predicts that, okay? I mean, it wouldn't make sense to say test 2 predicts test 1. It only makes sense in this case that test 1 predicts test 2. Sometimes when you measure the variables at the same time, it's kind of ambiguous which one predicts the other one, okay? But in this case, it makes sense to make test 1 the x variable and test 2 the y variable, but it's not always as cut and dry, so just keep that in mind. So here we're going to get the means first, like I said. So I want to use the average function, so I'm going to go equals average and then parentheses, highlight this data, and then close the parentheses to get the average of test 1. So the average of test 1 is 78.6. Now I'm going to get the average of test 2. So So I'm going to put equals average, parentheses, highlight the test 2 data, close the parentheses, and press enter. And so the average for test 2 is 86.2. Then I want to get the deviations for both test 1 and test 2. And to do that, I'm just going to go here, press equals, click on the first observation for test 1, and then subtract off the mean, but I'm going to type in the mean instead of clicking on it. And you need to do that for what we're going to do next. So after I press enter, you want to go back to the cell and then go to the bottom right until we have this black arrow, this black cross, and double click. And now we have all the deviations. So Excel won't work right, won't do what we want unless we type in the average instead of clicking on it, okay? So now we have the deviations for test 1. So this one again was B2, which was 84, minus the mean of 78.6, and then this one, for example, is B3, which is 50, minus 78.6, and so on, okay? And it accidentally did it for this row, which I don't need it. I'm going to delete it. We only want it for the 5 observations. And it did that because I already had this here, but that doesn't matter. And then we're going to do it again for test 2. So we're going to equals, then click on the first observation for test 2. Subtract off its mean of 86.2, and again I want to type it. Press enter, click on the cell again, go to the bottom right and double click, and now it did it for each of our observations. So this one was, for example, C3, which is 84, minus the mean of 86.2. So now I have the deviations for test 2. Now I want the products, because that is the top of the formula, which is the sum of products, and to get sum of products first you need the products. So the products is the multiplication of the 2 deviations. So we're going to say equals, and then 5.4. I want to click on the cells so it will do the rest of the deviations for me, and then I'm going to go Shift 8 for me anyways, which is the asterisk, and that means multiplication. So asterisk, the star looking thing, it means multiplication. Then I want to click on the deviation for test 2, so I'm going to have D2 times E2, and then press enter, and that gives us our first deviation. But we want the rest of them, and so I'm going to go up here and double click, and then again it tried to keep going too far, so I'm just going to go here and delete that. Alright, so now we have the products. Now I want the sum of the products. So I'm going to put equals sum, use the sum function here, and then highlight all the products, close the parentheses, and press enter. So the sum of the products, so the sum of all these values is 52.4. Now you can check this in your calculator if you want, you don't have to use Excel, but I'm just going to do that. So now I have the top of the formula here, which is the sum of the products. Now I need the sum of squares for x. So to get the sum of the squares, I need the squares. And remember, our x variable we decided to be 1, the test 1. So you need the squares of the deviation. So I'm going to click on the deviation for 1, the first one, which is D2, and then I'm going to put a caret, which for me is Shift 6. And the caret means we're going to go, you put a 2 behind it, means you're going to square it. It's just the exponent symbol. So D2 caret 2 means we're going to square it. Now press enter. And then I want to make this go down for all my 5 observations. So I'm going to go to the bottom right and double click it. And again it went a little too far because it's not an observation. So I'm going to delete that one to 0. And then I need the sum of these squares. So again, but again it did it for each of them, right? It did D3, which is the deviation for 1 for student 2, and so on. Then I want to sum those, so sum of these squares. And there we go. Press enter. So now I have the sum of squares for x, which is our test one. And then I'm going to put equals. So now I'm going to actually get the slope. So I'm going to put equals, and then I'm going to get the sum of the products divided by the sum of squares x. And then press enter. So our slope, I don't know why I put that there. So our slope is 0.044978082. So that is our slope. So I'm just going to review really quickly how we got the slope. So I found the sum of the products and divided by the sum of squares for x. So the sum of the products was 52.4, and the sum of the squares for x was 1165.2, and if you divide that, you'll get 0.04. And so basically we have on top we have the variability due to the relationship, and then on bottom we have the total variability in x to get our slope. So once you calculate the slope, it would help if you could interpret it. So there wouldn't be a reason to calculate it if we couldn't interpret it. Now I'm going to give you a generic sentence here. So this is kind of the sentence that you can base all your interpretations on. You take this sentence and tweak it for your specific problem that you're doing. So the generic version is, for a 1 unit increase in x, or your predicted variable, I predict y will increase by b units. And so y is your outcome variable, and b is your slope that you calculated that number. So let's do an example. And we'll continue with our example of the test score. So our slope was 0.04. So to write a sentence about that, we can say, for each additional point on exam 1, I predict that exam 2 will increase by 0.04 points. So I repeat that. For each additional point on exam 1, I predict that exam 2 will increase by 0.04 points. And so that's how you can interpret the slope. Let me ask you one more question. So for each additional 10 points on exam 1, what increase in exam 2 would you expect? So you can think of it as, for each point it was 0.04, so 0.04 plus 0.04 plus 0.04, you do that 10 times, right? For each point, that'd be 0.4 points. Or you can calculate that by 10 times the slope of 0.04, and that ends up being 0.4 points. So if this slope isn't interpretable by itself, right? It is interpretable, but 1 point might not really tell you much in the grand scheme of things, especially on a test, right? 1 point's not too big of a deal, but 10 points is a letter grade. So maybe it's more important to interpret it by a letter grade, so by 10 points instead of just 1 point. So this is kind of a trick that you can use if 1 point's not very meaningful for your problem.